These are some example problems for one-dimensional motion with constant velocity. I'll be using this yellow background for example problems just so that you can keep them separate pretty easily. So first, I'm going to say you start from home and you walk 400 meters. This takes you 200 seconds and we're going to see how fast are you walking. I'll write that down. We are looking for how fast are you walking. So right here, how fast? There's our actual question. We want that speed. We are starting from home and we can pick anywhere we want to be our x equals 0. So we start from home. I will say x initial equals 0. We walk 400 meters. X final is going to be 400 meters. And it takes 200 seconds to do this. That sounds like a time duration. I will set up a table for myself because that's what I tend to do with these. The only things that we could possibly have: x initial, x final, speed, and a time. We know our x initial is 0. Our x final we said is 400 meters. Our v we don't know, but that's the one we're looking for. And our t, that's 200 seconds. Now I know full well that setting this up is overkill right now, that pretty much all of you will have been looking at this and saying, you're going 2 meters per second. That's it. Stop doing work. But by setting up a system like this, we have something that's going to be able to be very algorithmic. This same system will work for more complicated questions where the answer isn't as immediately apparent. For constant velocity motion, we really only have one equation, and it looks like this. We are looking for v. We have all the pieces we need other than that, so I will start substituting in. We know x initial is going to be 0, and we are saying x final equals 0 plus v, which we don't know, times t. You don't have to do this, but I do this as my own preference. I will use red to be my unknown variable that I'm solving for. As the equations get longer, this one's not, but as the equations get longer and longer, it can be a helpful thing to be able to look at it and very quickly pick out, hey, this is what I know, that's what I don't know, that's what I'm solving for. So that's what I'm going to do. I've got x final as vt. I'm trying to get v by itself, so I need to divide by t. I'm going to divide by t over here, divide by t over here, and I get x final over t on the left equals v. Now that I'm down to v equals something, I'm going to plug in my values. X final is 400 meters. Time is 200 seconds. And I get 2 meters over second, so 2 meters per second. Not too bad. That was an easy one. Let's try something a little tougher. Second problem. You drive at a speed of 25 miles an hour. We're going to do that for 2 hours. How far are you from where you started? I'll write it down. Okay, we are looking for how far are you? How far from where you started? It looks like we are looking for x final. Where you started, we can pick anywhere we want to be x equals 0. I'm going to say x initial is 0. We have 25 meters per second, and we're even told it is a speed of 25 meters per second. Our velocity is 25 meters per second. It doesn't matter whether we're moving in the positive or negative direction because we're starting from 0, and in the end we're looking for how far we've traveled, so we're going to take a positive value in the end anyway. We are doing this for 2 hours. That sounds a lot like a time. And now we've run into a little bit of an issue. We have a speed in meters per second. We have a time in hours. I don't want my time to be in hours, or I don't want my speed to be in meters per second. It's easier for me to convert this thing that's in hours. I want it to be in seconds so that it matches. So I know 1 hour is 60 minutes. So that hours and hours can cancel. I know 1 minute is 60 seconds. And minutes can cancel. 2 times 60 times 60 is going to be 7,200 seconds. Now I can set up my table. I'm going to scroll up a little bit. My table has the variables that I could have in here. So x initial, x final, v, t. And here we go. X initial is 0. X final, I don't know, but I'd like to. V is 25 meters per second, and T, that's 7,200 seconds. I'm going to start with my equation. X final equals x initial plus v t. X final is the one I'm looking for, so I'm going to put that in red. And this is convenient because it's already by itself on this side of the equation. I don't have to do any algebra. I just have to start plugging in numbers. I'm going to plug in my 0 here. So x final equals v times t is all that I'm left with. So I get 25 meters per second, 7,200 seconds equals 180,000 meters, which is probably not the way that I would give that answer. I would probably say that's 180 kilometers. That's it.